Today we're going to be studying mathematics
and emerges from the second mirror.
These words sound
Be your teacher for today.
Hello student, this is another beautiful day in the series of your EduTech home lesson, online home lesson. So we are about to round up with the module 1. This is the last topic in module 1. Stay enjoying the topic. Now we look at algebra of vector. Algebra of vector. Algebra of vector is the arithmetic we do in handling vector issue, vector problem, or vector analysis. But we cannot talk about vector and not talk about scalar quantity because the two of them are inseparable. What is vector quantity? So the quantity that has both magnitude and direction. Because of the issue of the magnitude there, and that will make us to look at what is scalar quantity. Example of vector quantities are example like displacement, acceleration, time, velocity. Those are example of vector quantity and force, etc. Those are example of vector quantity. But for scalar quantity, we have the distance. We have as the vector quantity. We have another temperature as the scalar quantity. They only have both magnitude but no direction, and that is because of the magnitude now that is bringing in the concept of a scalar quantity. That's not how we can look at vector without not mention about scalar quantity. So that's all about that. So in vector quantity, we talk about vector representation. There are three ways you can represent a vector. You can use a line with an arrowhead with a tail to represent a vector. You can adopt the uppercase or lowercase letter with an arrow indicating the direction on the letter. For example, for vector representation, I can use a line like this. We put the head here. This is a vector quantity. It's showing the direction. The length of the line gives us the magnitude of the vector. The magnitude of vector. Actually, if you want to get the magnitude of vector, you can place a ruler here. Since it is scalar quantity, magnitude is a scalar quantity, so it's not difficult to get scalar quantity. Just put a ruler between this point and this point, then whatever you have on the ruler is the magnitude of the vector. Now we have here to be the magnitude of the vector. That's the numerical value of the vector. So this is the direction of the vector. So that now make this line to be a vector quantity. This is the magnitude, this is the direction of the vector. Now you can also represent vector in this way. Vector A, put an arrow on the top of letter A, or a small lowercase letter, put an arrow on it. Those are the way you can represent vector. So in any case, in any issue, you see a letter represented like this, or a line like this, it tells you that it's a vector quantity. So you have to take your time to understand it and know how to perform the algebra. So we are going to consider the following illustration. Under the addition of vector, we are going to use line and how to see we can add them together, and we are going to use letter, the uppercase or the lowercase as the case may be, and how we can see and how to add them together. If we are given a line like this, and that is vector A, and we are given another line like this, that is vector B, one thing you need to understand is this: to add the two of them together, you must not alter the magnitude of each of the vector. You must not change the direction. Those two things are very, very important. What I mean by that is that if you want to add this to this, don't make a vector A longer than the way it was. Now, look at the vector A. It's not following the same magnitude. So you have to consider that. Use the same magnitude and you face you use the same direction. Look at the direction. A is facing like this, so also yours should face like that. Then that is vector A. To add vector B to it, the tail of vector B will begin from the head of vector A. This is the head of vector A, this is the head of vector B. But we want to add B to A. B will come like this in that same direction. That's the head. This is the tail of B. So this is vector B. Our resultant result now must be in vector form, which is this place now. That is our answer. The big question we now have now is that where should we put the head? Where should we put the tail? Should we call this place the head or call this place the tail? That's the big question we have now. So how do we get the head? Since we are adding vector A to vector B. Now this is the head of the second vector, which was added to vector A, and that is where the end of our resultant vector will be. So where the in vector addition, the last vector, that is where the head of your solution or the vector that gives you the answer will be. So there will be two heads here and two tails here. These are the common things we normally use to recognize the vector, resultant vector, when you perform vector addition. The resultant vector, which is called vector R, that's the resultant vector. I call it vector R. The resultant vector now is vector R. The tail of the resultant vector must be joining the tail of your first vector, and the head of your first and your resultant vector must be joining the head of your last vector. So vector R is the resultant vector. So to write the equation for that now, vector R is equal to vector A plus vector B. This is how to perform vector addition vectorially. That's all about using a line and adding the two of them together using vector addition vectorially. So the next one we'll be going to now is how to use uppercase letter, how to perform the addition too. So this is addition of vector. This is what we call a IJK vector, that is two-dimensional vector. In performing this addition of these two vectors together, vector A is given as 2i, meaning that I is on the x component, j is on the y component, k is on the z component. So to add the two of them together, to perform the addition of the two of them together, so you add this plus this, so that is 2 plus 2i plus minus I. So we can take the coefficient, that is 2 plus minus 1 I, then plus we have 3 plus minus 2 j, we have plus minus k plus 3 k. So this one will give us 1 I. This and this time this will give us minus 2. That will give us plus 1 j. So this and this will give us plus 2 k. So that's the addition of the two vector A plus vector B. That's the answer. So I, j plus 2k. That's the solution of that. Subtraction of vector. When we represent vector with a line with an arrow head, we can equally subtract the two of them. If consider the following vector, vector A and vector B. Now we want to find A minus B. That is what we are looking for, vector A minus B. So you keep the sense, like I've said, and you keep the magnitude. You keep the sense and you keep the magnitude. So when you look at the sense, this one is facing here. We'll start like that. That is the magnitude. That is the vector A. Now, B is coming down like this, so you follow that. That is vector B, following that. That is vector B. Since we are subtracting vector B from vector A, the direction will be reversed. The direction of this vector will be reversed. That is what we do in vector subtraction. So the head will no longer be here, the head will be here. The direction will be reversed in this form. This is vector B. That is vector subtraction. So we now connect this place. That's our resultant vector. Like I said, our tail of our resultant will still be with the tail of the first vector, which is A. This is the tail, this is the head. So this one, so the head will still be here. So is that the head will no longer be 2 here, just because the direction of B are being reversed. So this will now give us our resultant vector. Now to write the formula now for this place to know the resultant vector is going to be A minus A vector plus into minus B vector. This minus is very, very important to tell us that we have reversed the direction of the vector. That's how to perform vector algebra. So you can have it in such a way that they will draw the vector diagram for you there, and you may be asked to indicate the resultant vector. So you have to check number 1, how do they perform the vector? Is it vector addition or vector subtraction? So for you to know and to be able to determine your resultant vector. Very simple to determine. For vector addition, the 2 tail will be in one place and 2 head will be in one place. That is vector addition. But in case of vector subtraction, to determine the resultant vector, the 2 tail will be in one place and a tail at the end. Just observe that place where you have 2 tail. This is the only point you have 2 tail. Here we have a head and head. Here we have a head and tail. Here we have a 2 tail. So you can easily determine that this is the resultant vector, and this vector is a vector subtraction where there is 2 tail and a head and a tail. In case of addition, you have 2 tail and 2 head. That will help you to determine that vector that possesses that nature with 2 tails to the first vector, then and the other head with the first vector will give you the resultant vector. Subtraction of vector under this IJK vector. So IJK vector, like I said, I is on the x-axis, J is on y-axis, K is on the z-axis. If we are to represent them, just draw the graph. Just put it like this. We have a y, x. This is 2i. This is 4j. That's how to do it. This is the k vector minus 3k. This is j is talking about y-axis. I is talking about x-axis. K is the z-axis. So this is actually 3-dimensional problem. That's how to represent that. Now, so for you to subtract this from this, you carry the magnitude, deal with the magnitude only. We have 2 of this. The coefficient of this one is 1. Give us I. Come to this one plus. So carry the coefficient here 4. We are subtracting minus minus. Don't forget there's an existing minus here, but we are subtracting, making the minus to be double. So plus. Now we have minus 3 minus 5 k. So when you subtract this one, we have I. This time this plus, that is 7j. Now this time this. Now this minus, that's minus 8 k. So this is the final solution to that problem. So I plus 7j minus 8k. So in vector resolution, we have the y-axis and the x-axis. This is x, this is y, and there is a vector in between the y-axis and the s component. So such a vector must be resolved. That is what we call vector resolution. There is a band here, the y axis and the S axis. Then in between the Y axis and the S axis calls for resolution. But when the vector is placed on the Y axis, we don't resolve. And even though you resolve, it still gives you the same answer. Nothing will change. So you take it at first because that vector is already positioned on the Y axis. For example, if I give you 4 Newton on the Y axis, X, 3 Newton. Now, these two forces now are being resolved, meaning that this is the value of the vector on the Y axis, meaning that this one has no S component. So it only has Y component, because when vector is between the Y axis and the S axis, it has 2 components. So you need to determine the component of that vector on the Y axis and also determine the component of that vector on the S axis. The method of doing this is what we call a resolution of vector. You are trying to resolve that vector. But once you are given like this and you are given like this, you can calculate the resultant first vector. Take for example, this vector is 4 Newton, this vector is 3 Newton. I want to find the resultant. Find the resultant. Find the resultant vector. Find the resultant vector. All you need to do is that you connect this place together. That will give us the resultant vector. Here is our resultant vector now, R. So apply your Pythagorean theory. We give us the resultant vector for this. So the solution now will now be, so R equal to root of 4 square plus 3 square. So which is equal to 16 plus 9. So R will now be equal to 25. Root of 25, which is 5 units. So that is the resultant vector, because this vector is already on the Y axis and on the S axis. To determine the resultant is very, very easy. But in case of this, you have a vector here 4 Newton and here maybe 30 degree. You cannot determine this one like this. So you have to go through vector resolution. Now, to determine this one now, in vector resolution, the y of this vector, the y of it, will now be the force sine theta. This is the y component. The s component of this will now be f cos theta. So anytime you want to resolve a vector, this is the formula you use for the s component, while this is the formula you use for the y component. So the answer you get here now, you now place it on the y, and the answer you get here now, you place it on the x. For y component, we are going to use this formula. So we have y equal to f sine theta. So our f is the 4, our sine 30 we have equal to 4 times sine 30 is 0.5. So they give us 2 Newton. For s component now, we use f cos theta. Our f is still 4 cos 30. So we have 4 times 0.8660. That is the minus. So that's 0.5. 0.5. So Newton. 0.5 Newton. 0.5 Newton. So we now represent this one now on the s-axis and on the y-axis. On the s-axis and on the y-axis, we now have y-axis like this, 0.5, s-axis like this, 2n. And when you multiply this and this, we have a 3.464 Newton. Now, we are going to represent this one back into x and y coordinate. Reason is that you have to consider the values you have here. In representing the answer to get our resultant, in representing our answer on the x and y, because on the Cartesian coordinate, we have negative side of x and positive side of x, negative side of y and negative side of x, which is this. This is negative y, this is positive y, this is negative y, positive x, this is negative x. Now, looking at our answer here, y is positive. So I'm going to pick this side and put 2 Newton here. My answer here, x, is also positive. I'm going to use 3.464 into that place. I didn't mean that our answer here is negative. I will put my x here. If my answer in y is negative, I will put it here. That one is very, very important. Now, and again, for you to resolve here, you have to consider here. Let's say your answer here, your s here is negative. You have to consider it too. Let's say your y here is negative. You have to consider it too. And put the negative into the formula before you go on with the formula. So if you do that, our graph will become like this. We don't need this negative side. Our graph will come like that. So we now close this place. So this is now our resultant, R. So we now calculate it now. We now have R equal to the square root of 2 plus 3.46. Square it. So we have R equal to 4. So if you square this, 3.46 square, you have 11.99. So if you add the two of them together, you have 15.99. If you get the square root, you have 3.99 Newton. So that will give us the resultant. Since it is a vector quantity, we need to determine the direction. Now, this is the magnitude. So anytime you are given problem on vector, whether you are asked to calculate the direction or not, you need to get it, because it is a vector quantity. So it has both magnitude and direction. So the resultant now is 3.99. To get the direction now, that is the angle, the theta. So we use tan, which is the opposite over the adjacent. So tan theta, the opposite over the adjacent. So the tan theta, the opposite is 2, the adjacent is 3.46. So we divide it. So we have tan theta to be equal to 0.578. So now find the inverse of that. Tan inverse of 0.578, which is now equal to 30.2, approximately 30 degree. So that is the direction. So if you want to locate it now, you can put it as the northwest, that direction. So northwest. Looking at the concept of the vector, these are the questions that you find interesting when you go through them, and to also help you further in your study. Problem 1, given that vector A equal to 2i plus 3j minus 5k, vector B minus 4i plus 5j, vector C 3i minus j plus 3k. So you have to find number 1, vector A plus B, 2, vector A plus C, 3, vector A plus vector B plus vector C. The second problem is vector A equal to I plus 3j minus 5k, vector B equal to 4i plus 5j. Find the magnitude of vector A minus vector B. So the top problem is 6 Newton on the y-axis, 8 Newton on the x-axis perpendicular to each other. So the diagram above shows two vectors at right angle to each other. The value of the resultant vector is, you have to determine that. Question 4, the resultant of the two forces is 50 Newton. If the forces are perpendicular to each other, one of them makes an angle of 30 with the resultant. Find its magnitude. The last one, question 5, is a vectorial problem. This is vector P, vector R, vector Q. So the figure above illustrates three vectors P, Q, and R. So write the correct equation for the resultant vector. Now this will bring us to the end of module 1. So you are expected to go through all the topics in this module 1 and ensure you understand them very well before you make an attempt of writing the examination. There's going to be an exam at your own comfort zone, at your own home there. The exam will be scheduled for you, and ensure you read and have a proper understanding to all these questions that you have put across to you in the topic in all of this module. Go through them, because you may likely find some of these questions in the exam, and for better understanding. So as you read, I wish you good success in your forthcoming exam.